We're on lesson 2 of chapter 8, which is the slope of a line. First, we're going to find the slope of a line. Then we'll find slope when given 2 points. Then we'll solve a real-world problem. The slope of a line indicates the direction that a linear equation line is going. Slope is generally put into 4 different categories. We have positive slope, like if you were going left to right, you'd be going uphill. There's negative slope, so if you were going left to right, you'd be going downhill. There's zero slope, so no hill at all. Then we have undefined slope, which would just be like dropping off a cliff. No matter what kind of slope we have, it is all determined by the same formula, which is the rise over the run, or the change in y divided by the change in x. For example, if we start here at 0, negative 1 on the coordinate plane, and I want to get to this next point on the line right here, and that's 3 spaces up and 2 spaces to the right. In other words, it's a rise of 3 in y and a run of 2 in x. My rise would be 3, my run would be 2, so my slope in that case would be 3 over 2. And that slope is going to remain the same for the rest of the linear equation. So let's find the slope of these lines then. So it says find the slope of line A and line B. So line A is this red slope here. So on this coordinate plane, I see that line A crosses through 1 and 2. And then its next point here is 6 and 9. So what is our slope for that? Well, I know that the slope is the rise over run. So first we can start at our original dot and rise to the next one. 1, 2, 3, 4, 5, 6, 7. So we had to go up 7 to get to the next one, so our rise would be 7. Now we can calculate our run. So if we go back to that spot, our run would be 1, 2, 3, 4, 5. It took us 5 steps to get to the next dot to the right. You notice how we went up, meaning that the y value increased. That's why it's a positive 7. And you notice how we went to the right, so the x value was increasing. That's why that's a positive 5. If we would have gone to the left or down, that makes those negative. Since this is a positive 7 over positive 5, I notice that's a positive slope. And if you remember our last slide, positive slopes go up as you go to the right. And that's what this one does too. Now let's look at line B. Going from left to right, line B's first point is 2, 8. Its second point is at 8, 6. So now let's calculate that slope, the rise over run. So I notice for my rise, it's actually going to be a fall. We're going down 2. So since we went from 8 down to 6, that's a loss of 2. So that's actually a negative 2 rise. How about the run? 1, 2, 3, 4, 5, 6. Negative 2 over 6. If you can simplify that, do so. So we have negative 1 over 3. So that would be my slope. Here I notice it's a negative slope, and negative slopes do go downhill kind of if you're going left to right. Y is decreasing as x is increasing. That's the idea of a negative slope. Now we're going to find slope when given 2 points. So it tells us to find the slope of the line that passes through 1, 7 and 9, 1. Well, I know that rise over run is the change in y over the change in x. So if you look at the y's here, we have 7 down to 1. If you notice that I said it went from 7 down to 1. That would be a drop of 6, so negative 6. The x's went from 1 up to 9, so that is a change of positive 8. So I have negative 6 over 8. If I'm going to simplify that, that becomes negative 3/4. And that's as simple as it gets. So negative 3/4 becomes my slope. Now we have negative 3, 4, and 3, negative 4. So let's look for the change of y. We have positive 4 down to negative 4. That's a drop of 4 to 0 is 4 down to negative 4, so that means drop of 8. Then my x's go from negative 3 to positive 3. That's an increase of 6. I could also simplify this. This would turn into negative 4 over 3. And I usually like to keep these as improper fractions because it tells me the rise and run perfectly. Let's solve a real-world problem. It says the table shows the volume of water released by the Hoover Dam over a certain period of time. Use the data to make a graph. Then find the slope of the line and explain what it shows. So it looks like time will be my x-axis because that's usually an independent variable. If we count by 5s on every 2, that would be 5, 10, 15, and 20. Then it looks like I should probably count by 100,000s. So that would be 100,000. This will be 200,000. And this becomes 300,000. So after 5 minutes, 75,000 gallons have been released. So we could plot that right about there. After 10 minutes, 150,000 gallons have been released, which is right on that point. 15 minutes is 225. And 20 minutes is 300,000. You notice this is following a linear equation. So we could plot this point out. Now if we're going to find slope, if you remember slope is rise over run. And then rise is the change in y, run is the change in x. We could just look at this table here. It went from 75,000 up to 150,000. That's a change of positive 75,000. The run between those points was from 5 to 10. That's a change of 5. And notice we have that same slope for all of these. This goes up 75,000, that goes up 5. So does these. So if I do 75,000 divided by 5, that gives me 15,000. And that tells me that for every second of time that passes, 15,000 gallons are released by the Hoover Dam. So that's what we'll say, 15,000 gallons for every second.